The mysterious city of Machu Picchu is no longer occupied. It's been empty for nearly half a millennium.
You began to see within this the outline of a doorway.
And we're talking about ultimately being able to recover the power that Pachacutec possessed.
There is a mountain in Peru that has been photographed more times than almost any other place on Earth, and yet almost nothing you have seen of it is complete. Millions of tourists climb the same stone steps every year, stand at the same lookout point, and take the same picture of the same terraces framed against the same jagged green peak. They believe they are looking at Machu Picchu. What they are actually looking at, according to a wave of research that has quietly accumulated over the last several years, is a thin outer shell. A postcard stretched over something much larger, much older in its engineering logic, and much stranger in its purpose than the story most of us grew up with. This is not a story about aliens or lost civilizations with impossible technology. It is a story about what happens when modern science, genetics, ground-penetrating radar, seismology, and old-fashioned archaeology is finally pointed at a place everyone assumed had already given up its secrets. And it is a story about timing, because the closer researchers have gotten to understanding what Machu Picchu really was, the faster a very different kind of project has been racing toward the same mountain. Let's start with what we thought we knew. For most of the 20th century, the standard explanation for Machu Picchu was simple and, frankly, a little boring. It was built around 1450 by the Inca Emperor Pachacuti as a royalist state, a private retreat where the ruler and his court could escape the political pressures of the capital at Cusco. It was elegant, it was remote, and it was abandoned less than a century later when the Spanish conquest tore the empire apart. Tourists were told this version for decades, and for a long time nobody had a strong reason to question it. The site was excavated, mapped, restored, and turned into one of the most visited archaeological attractions on the planet, all under the assumption that its function had already been figured out. That assumption started to wobble when researchers actually began looking closely at the human remains found at the site. Machu Picchu has never given up its dead easily. Only a modest number of burials have ever been identified within the citadel, tucked into caves, terraces, and small chambers scattered across the site. For years, these burials were treated as background detail, confirmation that people lived and died there, nothing more. But when newer analytical techniques became available, particularly isotope analysis and ancient DNA sequencing, researchers realized that these remains had a lot more to say than anyone had bothered to ask. Isotope analysis works by looking at the chemical signatures locked into human bone and teeth, signatures that come directly from the food and water a person consumed during specific periods of their life. Different regions have different geological and agricultural profiles, so isotopic ratios function almost like a passport stamped into the skeleton itself. When researchers ran these tests on remains from Machu Picchu, the results did not describe a single homogeneous population living quietly in a mountain retreat. They described people from dramatically different parts of the Andean world and beyond it, coastal populations, highland populations, and individuals whose chemical signatures pointed toward the edges of the Amazon lowlands, a landscape separated from Machu Picchu by some of the most punishing terrain on the continent. That detail matters more than it might seem at first. The journey from the Amazon basin to the high Andes is not a pleasant hike. It requires descending through dense, humid lowland forest, then climbing thousands of meters through cloud forest and exposed alpine terrain where the air thins and temperatures swing wildly within a single day. It is a journey that would have taken serious planning, resources, and motivation, whether the people making it were doing so voluntarily as part of religious or diplomatic obligations, or were moved there as part of a broader imperial strategy. Either way, the presence of individuals with such varied origins tells us that Machu Picchu was never an isolated, self-contained retreat. It was a node in a much larger network, one that pulled people and resources from across the breadth of the Inca Empire. This lines up with what historians already understood about how the Inca state operated more broadly. The empire ran on a labor and resettlement system that modern scholars often refer to by its Quechua name, and one of its defining features was the deliberate relocation of communities, sometimes for agricultural purposes, sometimes for military security, and sometimes to bind newly conquered regions more tightly to the imperial center. Seen through that lens, a genetically diverse population living and dying at Machu Picchu is not a mystery so much as a confirmation. This was not a private hideaway. It was an administrative and ceremonial hub deliberately staffed and populated by people drawn from across an empire that stretched, at its height, from modern-day Colombia to Chile. None of that requires a hidden conspiracy to explain. But it does require us to throw out the postcard version of the story And once you start pulling that thread, the rest of the site starts looking very different too. If the bones told archaeologists that Machu Picchu's population was more complicated than expected, remote sensing technology told them the physical footprint of the site was too. LiDAR, light detection and ranging, has become one of the most transformative tools in modern archaeology. Aircraft or drones fitted with LiDAR sensors fire millions of laser pulses toward the ground every second. Most of those pulses bounce off leaves, branches, and the forest canopy, but a fraction slip through gaps and reach the actual ground surface beneath. By filtering out everything except those ground return signals, researchers can generate a three-dimensional model of the terrain as if the vegetation were never there at all. It's the archaeological equivalent of stripping away a curtain that has been hanging in front of a building for 500 years. LiDAR surveys have already reshaped our understanding of other major archaeological landscapes, most famously revealing sprawling networks of causeways, reservoirs, and urban infrastructure hidden beneath the jungle canopy in the Maya lowlands of Central America, cities that turned out to be far larger and more densely connected than anyone had assumed from ground-level excavation alone. It was only a matter of time before similar surveys were pointed at the forested slopes surrounding Machu Picchu, and when they found exactly the kind of thing LiDAR tends to find: structures nobody knew were there. Additional platforms, terrace walls, and architectural features have turned up on the slopes and ridgelines surrounding the core citadel, in areas that were previously assumed to be untouched wilderness simply because nobody had ever excavated them, and the forest cover made ground survey nearly impossible. This is not entirely shocking once you understand how Inca site planning worked. Inca engineers routinely built agricultural terraces, way stations, and ceremonial platforms across huge swaths of terrain surrounding their most important centers, and Machu Picchu was clearly no exception. But it does mean that the area we currently think of as Machu Picchu, the roughly rectangular core zone bounded by a protective wall, may only represent a portion of a much larger constructed landscape that extends well beyond the boundaries tourists are allowed to see. That raises an obvious and slightly uncomfortable question. How much of the surrounding valley has never been surveyed at all? Large portions of the terrain around the site remain covered in dense cloud forest, difficult to access, and outside the boundaries of formal archaeological study. Every new LiDAR survey conducted anywhere in the world tends to reveal that our previous estimates of a civilization's built environment were too conservative. There is no obvious reason to think Machu Picchu is an exception. While archaeologists were rewriting the human and architectural story of Machu Picchu, geologists were quietly working on something even more fundamental: why this specific outcropping of granite, out of an entire mountain range full of plausible building sites, was chosen in the first place. The region surrounding Machu Picchu sits within one of the more seismically active zones in South America, part of the broader tectonic system created by the collision between the Nazca and South American plates. Earthquakes have repeatedly devastated nearby Cusco throughout its recorded history, toppling colonial-era buildings and damaging structures that were, by any modern standard, well-engineered. And yet Machu Picchu itself has survived 5 centuries with remarkably little structural damage from seismic activity, despite sitting in the same general earthquake-prone region. Structural and geological researchers who have studied the site's construction techniques point to a combination of factors that likely explain this resilience. Inca masons famously built without mortar, fitting massive stone blocks together with such precision that a knife blade cannot slide between them. This dry stone construction technique, far from being a limitation, actually gives structures a degree of flexibility during seismic shaking that rigid mortared masonry lacks. The stones can shift slightly and resettle rather than crack and collapse outright. Combine that with the specific underlying geology of the ridge Machu Picchu sits on, and you get a site that appears to have been sited and engineered, whether through careful empirical observation passed down over generations or simply through trial and error across the wider Inca building tradition, to withstand exactly the kind of shaking that has destroyed other structures nearby. Whether the site sits at some uniquely perfect geological intersection, as more sensational accounts sometimes claim, is harder to say with the kind of certainty those accounts imply. Real geological research in this area is still ongoing and often more cautious in its conclusions than headlines suggest. What is well documented, though, is that Inca engineers approached the entire mountain as a single integrated system rather than a collection of separate buildings. And that becomes clearest once you look at what's underneath the terraces tourists actually walk on. Here is a detail that surprises most visitors. The terraces that make Machu Picchu instantly recognizable in photographs are not simply flat garden beds stacked up a hillside. They are sophisticated pieces of civil engineering, and a substantial portion of the effort that went into building them is completely invisible from the surface. Each terrace wall conceals a layered fill system beneath the visible topsoil, a foundation of large stones, followed by a layer of smaller broken rock, then coarse sand, and finally the topsoil that supports the crops on the surface. This layered construction serves two purposes at once. It provides drainage, allowing rainwater to filter downward and away rather than pooling and eroding the terrace. It provides structural stability, preventing the kind of waterlogged slope failure that destroys hillside construction in wetter climates. Interconnected drainage channels move water from the highest terraces down through the site, discharging it in a controlled way that has prevented significant erosion damage for 5 centuries through countless rainy seasons in a region that receives substantial annual rainfall. Engineers and hydrologists who have studied this system in detail have generally come away impressed, and rightly so. Designing a passive drainage network that continues functioning without maintenance for hundreds of years is a genuinely remarkable engineering achievement, regardless of the era in which it was built. It is one of the clearest pieces of evidence that Machu Picchu's builders thought about the site holistically, treating water management, structural stability, and agricultural production as interlocking parts of a single system rather than separate problems to solve independently. The astronomical alignment of the site tells a similar story about intentional, careful design. The carved granite pillar known as the Intihuatana, meaning roughly hitching post to the sun, sits at one of the highest points within the citadel. Researchers who have surveyed its orientation have found that its faces and angles correspond closely to solar events, particularly the solstices, consistent with its likely use as part of a ritual calendar system tied to agricultural and ceremonial cycles. Structures with similar solar alignments appear at other major Inca sites as well, suggesting this wasn't a one-off flourish unique to Machu Picchu, but part of a broader architectural and religious tradition that treated astronomical observation as central to how the empire organized both its ceremonies and its agricultural calendar. Put all of this together, the layered drainage engineering, the seismically aware construction technique, the astronomical alignment, the deliberately diverse population drawn from across the empire, and a very different picture of Machu Picchu starts to emerge. Not a quiet retreat for an emperor seeking solitude, but carefully integrated administrative, agricultural, religious, and possibly diplomatic center, built by an empire that treated engineering, statecraft, and cosmology as 3 faces of the same project. None of this research exists in a vacuum, and that's really where this story becomes more than just an update on old archaeology. Machu Picchu has struggled with the tension between preservation and tourism for decades. It draws well over 1 million visitors in a typical year already, a volume that conservationists, UNESCO officials, and Peruvian heritage authorities have repeatedly flagged as pushing the limits of what the fragile stonework, drainage systems, and surrounding ecosystem can sustainably absorb. Foot traffic causes gradual wear on stone surfaces that were never designed for that volume of use. Moisture from breath and body heat in enclosed spaces accelerates the growth of lichen and microbial colonies on stone surfaces. Vibration from constant movement, combined with the broader infrastructure needed to support millions of annual visitors, buses, hotels, waste systems, water demand in a region with limited water security, all place cumulative stress on a site that survived 5 centuries specifically because it was, for most of that time, left alone. Peru has periodically responded to these pressures with new management plans, visitor caps, timed entry systems, and long-term conservation frameworks aimed at balancing tourism revenue, which is a genuinely significant part of the regional and national economy, against the very real risk of loving the site to death. These plans are not perfect, and critics on all sides have found reasons to be unhappy with them, some arguing they don't go far enough to protect the site, others arguing they unfairly restrict access and economic opportunity for local communities who depend on tourism for their livelihoods. That tension is real, ongoing, and unlikely to resolve neatly anytime soon. Regional infrastructure development, including periodic discussions about expanding airport capacity to accommodate more direct international arrivals to the Cusco region, has been a recurring and genuinely controversial topic in Peruvian politics for years, well before any of the recent archaeological findings described above came to light. Supporters argue that easier, cheaper access to the region benefits local economies that depend heavily on tourism revenue. Critics, including many of the same archaeologists and conservationists studying the site's underlying engineering, argue that dramatically increasing visitor capacity without first solving existing water, waste, and structural preservation challenges risks causing irreversible damage to a site that took 500 years to prove how durable it actually is, and considerably less time to degrade. That debate is worth taking seriously on its own terms, without needing to reach for a hidden motive to explain it. Infrastructure decisions in any country, tend to move on political and economic timelines that rarely line up neatly with the slower, more careful pace of scientific research. It would not be unusual or evidence of anything sinister for a tourism infrastructure project and a wave of new archaeological findings to simply be moving on separate tracks that happen to overlap in time. The more interesting and better supported story here isn't a cover-up. It's the genuinely difficult, unresolved tension between preserving an irreplaceable piece of human engineering and the economic pressures that come with being one of the most desirable travel destinations on Earth. It's worth stepping back and asking why any of this should matter to someone who has never been to Peru and has no plans to go. The answer is that Machu Picchu is one of a shrinking number of places on Earth where we can still directly study how a pre-industrial society solved genuinely hard engineering problems: water management, seismic resilience, food production at altitude, long-distance logistics, and labor organization, without the benefit of iron tools, draft animals suited to mountain terrain, or a written numerical system in the form we would recognize. Every new technique applied to the site, from ancient DNA analysis to LiDAR mapping to structural engineering assessment, adds another layer to a genuinely impressive story about human ingenuity that has nothing to do with mysticism or hidden technology, and everything to do with careful observation, generational knowledge transfer, and a willingness to treat an entire mountain as a single engineered system. That story is more compelling, honestly, than any conspiracy theory could be. The idea that a society without wheeled vehicles or iron tools built a self-draining, earthquake-resilient settlement, staffed it with people drawn from across a continent-spanning empire, and aligned its most sacred structures to track the movement of the sun with genuine precision, that doesn't need embellishment. It needs continued careful study, responsible stewardship, and the kind of long-term protection that lets future researchers keep asking better questions with better tools. Whatever else remains undiscovered on that mountain, and there is very likely more, the more urgent story isn't a secret waiting to be hidden. It's a 500-year-old engineering achievement waiting to see whether the century that finally understands it is also the one that protects it.